Hi, my name is Ebrahim Goolam, and I was the senior marker for question 14 for the 2021 HSC Extension 1 Maths exam. Today, I'd like to share with you some of my thoughts regarding the marking of that particular question. Remember, that's the last question, and let's get into it. Okay, so you can see that unfortunately the slide is quite busy. However, I just want to point out that the left-hand side has got the question and a suggested solution, but the focus really should be on the right-hand side, the stuff on the right-hand side, where I will be focusing or talking about basically the student responses. And we've broken up this into 3 different categories. The first one is how or what we expect the students to do in this particular question. The second category is the better responses. How did they go about solving this particular problem? And probably the most important one, and that is the last one, areas where students need to improve. So let's start off with question 1. Now, to be quite honest, when I saw this question here, I was rather surprised. This is a classical vector problem that you find in most textbooks. And I was actually surprised that it came up in question 14. Having said that, when we started marking this, we could see why it was put in question 14. Anyway, the problem is pretty straightforward. It talks about, as you can see, a plane that is traveling at a certain speed, constant speed, and the wind, of course, pushes it along. So the first thing, of course, the students need to do here, like in every other question, and that is read the question very, very carefully, because it's a worded question, and interpret it correctly. That's the first thing we need them to do. Once they've interpreted this, we need to see a diagram, a clear diagram, a neat labeled diagram. And then, of course, use the appropriate formulae to solve the problem and find the bearing that was required. So that's what was required. And that's exactly what happened in some of the responses, the better responses. They drew a very, very clear diagram, showed the vectors very clearly, labeled it correctly, and then, of course, use their knowledge of bearings to arrive at the correct solution. Most of them, of course, use the sign rule, as you can see here, but others, of course, used trig ratios or vector resolution method, which is also, of course, appropriate and this problem can be solved using that method. It's a little more complicated. I've not taken the liberty of putting that here. You can try working it out yourselves. So they used appropriate vector components and trigonometric ratios to find the correct bearing. Now, the major problem with this particular question was the interpretation and the diagram. This gave us grief. It was very, very poorly done. The diagrams were terrible, to say the least. They were not clearly marked. We didn't know what they were talking about. The labeling was horrible. So that's one area that needs attention. The construction and clearly labeling of diagrams with the given information has to be done very, very carefully. And of course, to do that, students need to do lots more problems involving these type of situations using vectors to solve problems in motion. And of course, this could be, as I said, using the sign rule as we did here, or using the vector resolution method. So that was question A. Question B. In question B, we were basically given a differential equation. As you can see there, the differential equation was given and the right-hand side was broken up using partial fractions, and this was given in the question. And essentially, the job was to solve the differential equation given the boundary conditions, that means the initial conditions and another condition to find the 2 constants. The C here is your capacity, carrying capacity. And of course, there will be another C, which is the constant of integration if you decide to solve this problem using an indefinite integral. So what we expect the students to do here, of course, is to separate the variables in this differential equation and then to correctly integrate the terms that led to log terms. And then, of course, we expected them to correctly evaluate the constant of integration using the initial condition and, of course, find the capital letter C, which is the carrying capacity using the other condition that was given, which is T is equal to 20. The value of P was 600,000. In better responses, this was done in a slightly different way, and that is instead of using an indefinite integral, they use definite integrals, which just makes a lot more sense. I've not done that. You can do that. You get, of course, the same answer. But the beautiful thing about using definite integrals is that it obviates the need for the constant of integration. So areas where students need to improve was to make effective use of log and exponential laws to solve equations. Many of the students used the log and exponential laws or rules incorrectly. Also, they need to get experience or more exercise on rearranging and manipulating the terms to solve simultaneous log equations. And finally, of course, they need to solve lots more simple problems involving differential equations. Okay, so that was B. C had two parts. The first part was to show this very simple result. And of course, this can be done in two ways, where we let V equals some 2 or 3 component vector, let's say XY. And of course, using the product rule, we can actually get the solution out quite easily. Or alternatively, use the formula for the product rule or dot product and insert theta to be equal to 0, which gives us cos equals 1, and you get the result. So here, of course, students were expected to understand the fact that, or recognize the fact that the angle between parallel vectors is 0, and then of course use the correct notations for vectors and the magnitudes of vectors. This was a common problem actually. Students were using the incorrect nomenclature for vectors and their magnitudes. These are two different things. In better responses, of course, students were able to prove that the left-hand side is equal to the right-hand side, either using cos 0 equals 1, which is this approach here, or using this approach here. Areas for students to improve included doing practical problems involving proofs. They don't quite know how to do proofs, so they need more practice on that. They need to show all the steps. And of course, many of them were guilty of using specific values. Instead of using X and Y, they were using numbers like 2 and 3 or something like that. And you normally do that for solving proof problems. So they need a lot more problems, or to do more problems involving proofs using variables rather than specific values. C had a second part where you're given a trapezium with the diagonals, the magnitude of the diagonals were given to be equal, as you can see here. And you are asked to prove this particular result from the information given. The solution here is the way to go about doing it. There were other solutions, of course, and again, you can explore those yourselves. But in this problem, students were expected to express a vector in terms of sum of two other vectors, as you can see here. And then, of course, to make effective use of the information given in the question, that means the magnitudes were equal. And of course, use the fact from C1, the clue there that the squares of the magnitudes of each diagonals were to be used. So therefore, we square, and that's what happens in this. Once you reach that step and write it in terms of small a and b, the problem basically resolves itself. So in better responses, students were able to recognize the link between the results shown in part A and B, right? Or part 1 and 2 rather. And they used this effectively as a key to prove the second part. Areas for students to improve. When confronted with problems like this, it is important for them to understand or to recognize the importance of the information that is given in the question. In this case, of course, the fact that the diagonals were equal, for starters. They also need to carefully consider the implications of the words using part 1, which means they have to go back to the first part and see how does it relate to this particular question here, and use that in a multi-part question. Also, they need to distinguish between vectors and magnitudes of vectors using the proper notation for each. And of course, they need lots more practice doing vector problems involving proofs of geometric properties of polygons. Sorry. Okay, so a lot more practice on properties of polygons using vectors. Question D was a worded question, but it essentially broke down into a pretty straightforward problem involving stats, where we had a binomial distribution and using the Z-score. So in this particular question, you can look at the solution and the question later. They needed to identify the relevant statistical descriptors from the information given. As you can see, it's all there. The information is all embedded in there. So the mean value is there, the score is here, and we're basically comparing those two scores, and the variance is given here in terms of P. So all the information that is actually needed here, and of course the important point here, and that is the percentage here, 0.25, less than 0.25, which means that on your normal distribution curve, that the region there is what they're basically talking about. And of course, the important thing is for them to understand that we need to find the Z-score of a standardized normal distribution. That is what was needed in this particular question. So in better responses, the students were found the Z value using the empirical rule, using the fact that that's 2.5, and they found the Z value to be +2. And then, of course, they also showed a very clear understanding of the relationship between the score, which is that one there, the mean, and the standard deviation, and of course, they found the Z-score and used that to solve the problem. Now, the areas where students need to improve, again, involves the understanding of the difference between variance and standard deviation. Many students didn't quite know that this is actually the variance and not the standard deviation. And of course, they must know where to use each of these. The other important thing that most students missed, the ones that didn't get this out, and many, there were quite a few of those, and that is to find the Z-score. So they need to understand that we can use the empirical rule, right, to find out how many standard deviations the score is away from the mean, and whether it's on the right-hand side or left-hand side. In this case, of course, there's 2 standard deviations to the right. And of course, in order to apply this particular simple formula, they need to do lots more problems analyzing statistical data that exhibit binomial distribution. And then finally, we have question number E. This was probably the most challenging of the questions after C2. And in this particular question, they were given a polynomial, as you can see, and they were given the point through which it passes. And they were asked to find the gradient of a tangent of another function, which is the product of x and the inverse of g. So this is really an inverse function problem. Now, what we expect the students to do here, or what they should do here, is, of course, use their knowledge of the product rule of differentiation to find the expression for f dash. Remember, it is a product of 2 functions. They also need to understand the simple properties of inverse functions, and thereby understand that the G1, if G1 is equal to 3, which was actually given, there's it there, then G inverse 3 is equal to 1, because it's a 1-to-1 function, it's an inverse function. And then the other thing, of course, they needed to do is to apply the knowledge of inverse functions to determine the gradient of the tangent at the point. Now, in better responses, students correctly found the value of the derivative of the inverse function when x is equal to 3. And of course, they use the product rule to arrive at the correct solution, as you can see here. And some students, very, very few actually, used implicit differentiation to correctly solve the problem. But there were just a handful of those actually. Clearly, those must have been the extension 2 students. Now, the areas of concern here, or the areas that need improvement in this particular question, was I think students need to review the application of the product rule of differentiation, which is basically a year 11 topic, to understand, of course, the basics and the fundamentals of inverse functions, particularly this particular fact here, that if this is true, then that is the case. Not to confuse the gradients of tangents and normals with gradients of functions and inverse functions, which many of them did. And finally, to understand the relationship between the derivative of a function at a point A, B, and the derivative of its inverse at the point B, A. they need to understand that and have much more exposure to problems involving such situations. That's the end of the question 14. I hope you benefit from it. See you guys. Keep well. Bye.